Hello everyone, in this video I'd like to show you first steps that can be taken with Kyma Service Catalog. This is one of the core parts of Kyma and it already has predefined cloud provider brokers. So it should take only a couple of clicks in Kyma UI to have our first service up and running. I'm going to use Azure Service Broker and deploy Cosmos DB from its offering. Then after binding to the service I will create simple Lambda function that is writing to the database. Just for your information, I'm using free-tier Azure account and I already have Kyma on my cluster in version 1.4.0. Before we can start with deploying our first broker, we need to do some pre-configuration on our account. I will be using Azure CLI to do that. So first we need to create resource group. Let's call it My Cosmos. And we will create it on the location North Europe. Seems it's okay, so we need to now create application credentials on Active Directory. And we will call it Kyma. And we will save it to some file so that I can then use it as a to create a secret on Kyma side. So this will be the secrets Kyma will be using to communicate to Azure account. Just for convenience, we will expose the values as environment variables. So as you can see, the Azure subscription ID will be taken from Azure CLI, and the rest needs to be filled from the credentials we just generated. So I already passed the correct values, so we can just source the file. Now we can create actual secret on Kubernetes side using all the values that was just defined. And this secret named Azure Secret will be used to start our first broker. So let's clear up things here and move on to Kyma console. Kyma is shipped with first service broker called Helm Broker. It allows wrapping regular Helm charts as service offerings that can be then deployed in Service Catalog. Definition of those offerings are called add-ons, and it happens that Kyma has predefined add-ons for public cloud providers, brokers like Azure Broker. So in a sense, we are using broker to provision another broker that will allow provisioning service from its offering. It may seem a little complicated at first, but it's working pretty nicely, especially that you can expose your own add-ons easily. Just to give you a taste of how this works, I will update add-on config to point to Kyma latest add-ons release. So if we go to add-ons config, then you can see that we have the version of add-ons release 0.7.0. So let's copy the link. And we'll delete this config and create another one. But this time we'll use latest release. And now we should be using the latest set of brokers provided by Kyma. So now we can start the Azure broker. Let's go to the demo namespace, and in catalog we should be able now to provision our Azure Service Broker. By the way, here you can find some instructions on how to prepare your Azure account, which we already did. So we'll just add our broker now. Now in this place you can select the capabilities of the broker. So those are just the different groups of services. We will stick to the preview, and here we'll pass the name of our secret that we created in past steps. I just jump in time a little bit just to save your time. So we should have our broker already up and running. We can check it in instances, and it's here. And now we can check its offering on the catalog. So we now have 25 services exposed via this broker, and we can look for Cosmos to see all the offerings connected with Azure Cosmos DB. Okay, then let's create our first service on the cloud provider side. I would prefer to do it with a database account and database itself. So we are just clicking here and adding instance. You will just start very basic instance, choose the default plan, and see how it's going. Basically, settings doesn't matter at this point. I just want DB to be up and running. To select North Europe here, and our resource group with my Cosmos. I will also add IP range that will allow connection from Kyma. It's not a good idea to pass that wide range of IPs, but just for the purpose of this demo, I will allow such a range and just start an instance. And now we can go to the instances and see how the service is being provisioned. So broker already started provisioning, and in a couple of minutes it should be back with green status. But let's see. And I'm back after like 2 or 3 minutes with Cosmos DB running. I can even show you that on the Azure account it's already there. And just let's limit the output to the name of the database. And it's here. But let's move on to service bindings. Our service wouldn't be very useful if we couldn't connect to it. So to do that, we need some endpoint and credentials, and this is exactly what bindings are providing. So let's go to our service instance, and here we can create credentials for our DB by just clicking create credentials. And now if you access it, those are all the needed values or parameters that are useful to connect to your database. It also creates Kubernetes secret with this name on cluster side. And this is what we will be using in our next step, which is Python script that will be reading from the database. So let's have a look at the DB reader script first before we run it. So the most important part is that we are using Azure library to access the database, and the script is accepting basically 2 parameters. So the namespace with the secret and the secret name. And then we will just use it to first connect to our database, and then create first container, which is like the instance that keeps the data. Also, this is the instance for which you are paying. So at least at the point of recording this video, Cosmos DB in free tier is for free. So you start paying after creating first container and start making requests to this container. So just be aware that if you run the script, you could get some bills. But anyway, we create a container with the name demo, and then just pass the first data there. It will be just update with time not updated, and then it will be only done once if the container already exists. And as the last step, we will be just reading what was said in this first document. Before we run the script for the first time, we need to first set the kubeconfig environment variable, which is then used in the script to set the kubeconfig and then read the secret from the cluster. So let's do export kubeconfig, and in my case it will be the default one. And now we can run the script. So we are working on the demo namespace, and the secret name is this one. Yeah, so as a last line, you can see that it read this value from the first item. If I run it again, it should be exactly the same because we didn't apply any changes there. But I can change it very easily by creating lambda function. The function will be writing to the database, so I will call it dbWriter. And I need to copy code from the dbWriter.js file and paste it here. We need to also use Azure Cosmos library, so I need to use some dependencies. So the function is very simple. It's just connecting to the database and writing current time in the only item that is in the database. Also in the dependencies, I used Azure Cosmos library, and I will need to create some service bindings too, so that my function knows how to connect to the database. And as you can see in the code of the function, I'm accessing those parameters, those bindings, to have information how to connect to the database. So if you create the function, it should be more visible. So you can see that those parameters matches the ones from the bindings. So this way I don't need to care about the actual values. Those are just injected into my function. I still need to define how the function will be triggered. We can add the triggers here, and I think we can just stick to the exposing via HTTPS, which will mean that by accessing this endpoint, the function will be just triggered. We don't need authentication for the sake of simplicity, so I will just add it like this and save the function. So we can now view the settings in here. The status is still 1 out of 2, so the container with this function is restarting, so we need to wait for it to be available. After refreshing, looks like it's ready to accept requests, so we can go to APIs and now use this link to make our first access to the function, and as you can see, it returned the actual time and probably save it to the database, but we can check it with our Python script. So let's clear first and again run the reader. And as you can see, it has the updated time, so everything is working as expected. All the files that were used in this video can be found on my GitHub, and you can find the link below.